take care of stuff. On the grid, on your grid, I need you to follow me. You need to follow what I'm doing, where I'm putting things. Because if you don't, you're going to mess your grid up, and I'm not giving you a new one. Okay? Now, we're going to draw in the corner up here. In the corner. I'm in the corner. I'm going to draw a 3 by 3 square. Boy, today's lesson, you're in love. It's a Thursday. Yes, with your blue pen or matte pencil. Yeah, I'm sorry. With your blue pen or your matte pencil. I forgot to say that second period too. Do you want matte pencil? They're back there by the pencil sharpener. If you get it out of the Kleenex box, it goes back in there. Those are Mr. Jackson's. Okay, listen to me. On 8, today, you're in love. If you're tired, you're in love. Easy, easy, easy lesson. Simple. What? Now, you better think about this before you answer. What is the perimeter of this square? Raise your hand when you know. What is the perimeter of this square? Five people know. 6 people. 7, 8, 9, 10, 11, 12. Okay, you don't know the perimeter? Oh, I didn't see your hand. Okay, Willie, tell them. How'd you get 12? Thank you. And guys, we're going to call these centimeters. They're a little bit larger than a centimeter. It was centimeter of grid paper until I ran it off. Now, why? How did he get 12? Jay? Why did he multiply 3 times 4? He already told us that. Why did he multiply 3 times 4? Why didn't he do 3 times 5, 3 times 8? Why did he do 3 times 4? There's only 4 sides. Thank you for not saying 3 plus 3 plus 3 plus 3. That's why you learned your facts. That's what you did in 2nd grade when you learned perimeter. You counted 1, 2, 3, 4, 5, 6. Perimeter, you're counting the outside edge. Now, if I had a piece of string, I could take and put it around that, right? Because perimeter measures the outside distance, right? The distance around an object. Rim. Like the rim of the goal. Rim. Okay? 12 centimeters. Good job. Okay, today we're going to talk about scale factor again. The scale factor is 2. But we're not putting it on a coordinate grid today. We're just going to put it on a grid. We're really just putting it on a piece of paper, but instead of us measuring with rulers, I did grid paper that we could draw a coordinate grid on, but we're not. We don't need to put it in a certain place. Okay? We're going to draw it over here. Okay? Does everybody understand? Same thing we did yesterday. Exact same thing, except we're just putting it on grid paper. When I say the scale factor is 2, what do I mean? I'm going to multiply the dimensions by 2. So 3 times 2 is 6. So we're going to come over here and draw us a 6 by 6 square. And we're going to write the perimeter in there. So what's the perimeter? Because 6 times 4 is 24. We good? Come on, OCD people. We don't need it perfect. Just get it on there. OCD people. He don't just want to sin. Okay, here we go. From the last, hey, from this right here, count down 3 squares. Over here to the left, we're going to draw a 2 by 4 rectangle. 2 by 4 rectangle. Why did I do that? I've done that all day. A 2 by 4. Come on. Okay, what's the perimeter? 12. It's 12 again, isn't it? Different shape, same perimeter. Raise your hand if you can explain to me how you got 12. Okay. All right, guys. If you do 4 times 2 and 2 times 2, then you got to add them. And you got to remember what numbers. I'm going to show you an easier way. This is way easier. You do 2 things. What's 4 plus 2? 6. And then you got another 6 over here because it's the same size. So 6, double it, 12. That's just 2 problems. You can do that way, but I find the people that do that way, sometimes they miss it because you got to remember 2 numbers and then go add. So 4 plus 2 is 6. Double it, you get 12. It's just way easier, okay? All right. I know y'all learned that way a long time ago, but remember, I want y'all to do it the easiest way so you like math. I want you to like math. Okay, the scale factor this time is going to be 3. So what is my new rectangle's dimensions going to be? Yes, 6 by 12. Uh-oh. Uh-oh. You can't start right there. You got to count before you start drawing. That's what happened to me. I started drawing and then realized. What's the perimeter? 36. Where'd you get 36 centimeters? 18, 18 plus 2 there you go. Good, Dana. 18 and 18 make 36. Awesome. Okay. We good? Okay, now what I need you to do is skip down about 4. And we're going to draw a 1 by 4 rectangle. 1 by 4 rectangle. When I say go, everybody's going to tell me the perimeter. Go. 4 plus 1, double it, 10. Now the scale factor is going to be 5. The scale factor is going to be 5. We don't have room to go draw it over here, so we're going to come down below, skip about 3 squares, and we're going to draw it, and what are the dimensions going to be? 5 by 20. Okay, when I say go, tell me the perimeter. Go. That time I heard all the right answers. 50. 20 plus 5 is 25. Double it, you got 50. Okay, turn on the back. So far, so good, huh? Okay, in the corner up here, I want a 2 by 8. 2 by 8. Remember, what we're doing is we're dilating. We're making similar figures. The sides are proportional, correct? They're not congruent, they're proportional, corresponding sides. But I'm not putting them on a coordinate grid today. You can put them on a coordinate grid, or you can just draw it beside it on paper. When I say go, tell me the perimeter. When I say go, go. Guys, if you just get 10, that's just 2 sides. You're just going around half of it. Okay, the scale factor, speaking of half, is 1/2. So the dimensions are going to be, where did Kristen get 1 by 4? Half of 2 is 1. Half of 8 is 4. There you go. And the perimeter, 10. Good. We just did a 1 by 4 on the page before. Front page. Does everybody see how we got a 1 by 4? Okay. Skip down about 4. And we're going to do another 6 by 6 square. I hadn't messed up all morning. Might know when I'm recording I mess up. Okay, 6 by 6 square. What's the perimeter? 24 centimeters. Now I want the scale factor to be 1/3. So what are the dimensions going to be? 2 by 2. Where'd you get 2? 6 divided by 3 is 2. So the perimeter is going to be 8 centimeters. Good job. Okay, everybody's good to go? Okay, so far so good. Count down from yours. Let's count down 6 squares. And write the word pre-image. What does that mean, pre-image? It's the one we start with. Good. It's the original. It's the old. It's the one we start with before we do anything to it. Exactly. So you've got your pre-image. Okay. I skip down 6 more squares. And I want you to draw me a line that is 6 centimeters. That's going to be the base of our triangle. Now, I want you to think a minute. Don't say anything out loud. I want everybody thinking. Because remember, if I ask a question, I want everybody trying to think of something. I want you thinking of something. If I give you information, I want you trying to think of the next, what it reminds you of or whatever. I want to draw an isosceles triangle, and the height has to be 4. So I want you to think, where am I going to draw my height from? Thinking. Where am I going to draw my height from? The outside edge? Sean, where do you think? Right here? So if I draw, look, if I draw my side up 4 and I go over there, is that going to give me an isosceles triangle? Nope. What does isosceles mean? Tell them, Logan. No, that's equilateral. David? Well, there's a definition. Isosceles, Willie. No. Isosceles means two sides are congruent. Coach King taught me this a long time ago, what she taught her kids. Isosceles, I saw, two, with two. I saw. Isosceles, two sides are congruent. So if two sides need to be congruent, see, here's the problem. Now I bet half of you know where to draw the line from. You got to know the definition of words to know what you're looking for. So isosceles, where am I going to draw my height from, Jay? The middle. Good job. Okay, and I want you to do a dotted line. Just do a dash line up 4 centimeters and put your vertex. Then when you connect, somebody explained this very well first period. They said now the distance from that vertex to the corner is going to be, you got to go the same distance. If you're in the middle, correct? Okay. Okay, and write 4 centimeters across the height. Come down here. We're not going to put the perimeter inside the triangle. Perimeter equals. Raise your hand when you know the perimeter. Raise your hand when you know the perimeter. Nobody can tell me the perimeter. Nobody in here knows the perimeter. Sean? No. No. You don't know. How do you not know the perimeter? How do you not know? Well, okay, I hadn't called on Madison today. Madison. Yeah, it has one. It has one, but why don't you know it? Why can't you tell me yet, Emily? You don't know these sides. You don't know. You know that they're congruent, but we don't know what they are. The 4 has nothing to do with the perimeter. It's not on the outside edge of this. Now, sometimes the height is on the outside edge, but not this time. It's in the middle. So you don't know what these are. But guys, soon you're going to learn how to get this side. If you look at half of this triangle, that makes a right triangle. That makes a right triangle. And pretty soon you're going to learn, we're going to do Pythagorean theorem. And when you do Pythagorean theorem, that tells you on a right triangle how to get the length of one of the sides if you know 2 of them. When you get older and you're a welder or a carpenter or any kind of builder, architect, baseball coach, you're building something for yourself at home. The Pythagorean theorem is going to come in real handy. And part of it is the 3, 4, 5 rule. If you know a carpenter or a welder at home, sheet metal worker, if you know anybody like that, and you say, hey, do you use the 3, 4, 5 rule? The answer's going to be yes. I've talked to welders and all. They use it every day. Every single day, the 3, 4, 5 rule. Okay? Half of 6 is 3. This is 4. So that's got to be 5. 3, 4, 5 rule. If one side's 3, the other side's 4, then that side has to be 5 if that's a right angle. And it is. So now you can tell me the perimeter, which is 16 centimeters. Good job. Okay. And you don't need to worry about that. But you know what? When I first started teaching Pythagorean theorem, the kids are going, oh, this is hard. Pretty soon, you know what they say? This is the best thing we've learned all year. I love this. It's really not. It starts off, yeah, the name of it. You know what the hardest part of doing it is? Spelling the name. Spelling it. Okay, listen. But after they learn it, they go, oh, man. And at the end of the year, ask them, what was your favorite thing you learned all year? Pythagorean theorem. That was the easiest thing. Okay. Now, so this time the scale factor is going to be 4. But we don't have enough room to draw it. So we're going to come over here and just put the dimensions of it. Right image. Right image over here. Base. We've got height over there. And guys, these sides right here, if that's the base, these are called the legs. So just put leg. If the scale factor is 4, what's my new base going to be? My new base is going to be 24 centimeters. Good job. If my old height pre-image is 4, 16 is going to be my new height. The height of my image. The leg is 5. Now it's going to be 20. Now go get the perimeter of my image. Don't say it out loud. When I say go, we're going to say what we got. Get the perimeter. Are we all done? Y'all have an answer? Say no if you don't. You don't know how to get it? Go.
16.
No. 64. Okay, why is it 64? Tell them, Megan. Thank you. The height, I already told you that. The height had nothing to do with this perimeter. The height has nothing to do with this one. Very good, Megan and Willie. Who else had 64? Logan. Okay, thank you, guys. Shh. You've got the base and 2 legs. You have the base and 2 legs. So it's 64 centimeters. 64 centimeters. Okay, turn to the front. Now, I want you to study either your front page, you study yours, or you study mine, and you look and see if there's something you notice, but don't say it out loud yet. I'm going to call on somebody. You look to see if there's something that you notice happens on every one of them. on the front. Well, the back too, but. Just raise your hand right now if you notice something. You see something. 2, 3, 4 people, 5. You see something that happened. 6. Don't put your hands down. Once y'all see your head, okay, put it down. I need everybody looking and seeing if you notice something about the front. What happened? There's something special that happened. Okay. Tori, what do you notice? Okay, all of them started off smaller and got bigger. Why did they get bigger? Because the scale factors were all what? More than 1. Yeah, whole numbers. They were all more than 1. All bigger than 1. Okay, there's something else I needed you to notice. Kristen? There you go. So, look what happened. 12 times 2 is 24. 12 times 3 is 36. 10 times 5 is 50. On the back side, half of 20 is 10. A third of 24 is 8. And 16 times 4 is 64. It worked every time. Let's figure out why it worked every time. When we're doing the perimeter, y'all told me you're just doing the outside distance, right? It's like you take a string. So if I'm doubling the dimensions, finish that. If I'm doubling the dimensions, I'm doubling the perimeter. I'm just doubling the length of the string that goes around it. Guys, you need to understand that so tomorrow won't be so hard. If you're doubling the dimensions, you're just doubling the string that goes around it. That's all you're doing because it's one-dimensional. The perimeter is one-dimensional. Does that make sense? Okay. So, no. I just need your brain in gear. If your pre-image, if the perimeter's 10 and your scale factor is 6, what's my new perimeter going to be? 60. If my perimeter is 10 and my scale factor is 1/2, then my perimeter is going to be 5. Please, everybody listen. If my perimeter is 15 and my scale factor is 4, what's my new perimeter? 60. If my perimeter is 25 and the scale factor is 3, my new perimeter is going to be 75. Thank you, people that are participating. Tomorrow you're going to breeze right through what we're doing. If my perimeter is 20 on the pre-image and it's 100 on the image, what's the scale factor? What did you do to get 5? Okay, we learned to get scale factor. You take the new dimension and divide by the old dimension. Or you can do the coordinate, the new coordinate divided by old coordinate. Or now you can take the perimeters and divide. You can take the new perimeter and divide by the old perimeter. The image is the new, right? 100 divided by 20 is 5. Okay, so if 12 and 48, what's my scale factor? 4. Good. If my new image, my perimeter of my image is 90 and the scale factor is 3, what was my perimeter of the pre-image? If my perimeter of the image is 72 and the scale factor was 6, what's the perimeter of my pre-image? Good job, guys. 12 times 6 is 72. 72 divided by 6 is 12. Are we getting this? Okay? If, I'm going to make it a little harder. If this is 64 and the scale factor was 1/2, what was my pre-image? Oh, good. 32. How'd they get 32? Okay. All right. Are there any questions? So, let's put into words what you learned. Let's put into words what you've learned. Take the perimeter of the pre-image. Yeah, let's use our fancy words. If you take the perimeter of the pre-image, you're going to multiply by the scale factor to get the perimeter of the image. That's all you're going to do. Take the perimeter of the pre-image times the scale factor. So if you have these two, you've got to divide. If you have these two, you've got to divide to get that. If you have these two, you multiply. You do the opposite operation, don't you? So, does everybody get it? Understand it? Okay, good deal. All right. Put that in practice, please.